Good morning, gentlemen. Today is Wednesday, April the 29th, and today we are going to continue with our discussion of chapter 12 with section 12.2, the falling moon. Okay, so Newton, when he watched the apple, realized that it was falling. Okay, now Newton also did a lot of work deriving equations for two-dimensional motion and that sort of thing. So let's say you climb up to the top of the very tallest mountain on Earth and you throw a baseball, all right? It goes down and hits the ground here. Next time you throw it a little harder, it goes a little further. The next time you throw it a little bit harder and it goes here. And then eventually you throw it fast enough so that it goes, and this is going to be tough to draw, but pretend that's a perfect circle. It's hard to do with a mouse. All right, and comes back and it hits you in the back of the head. All right, so what Newton realized was that the moon is actually doing just what this theoretical rock or baseball or whatever it was actually was doing. All right, the moon has a tangential velocity, which is represented by this arrow here. Okay, and so what Newton figured was if the moon is falling, if the moon is falling, there we go. What that means is that if it falls at the rate of the acceleration of gravity that we all know and love, the 10 meters per second squared, then in the time that it takes to travel this distance horizontally, it will also fall this distance vertically, right? And if it wasn't moving with a tangential velocity here, it would simply fall to this point. So let's say that's a 1 second period of time. Well, this is a 1 second period of time. Now, obviously, it's moving a lot more slowly than that, but here's the idea. So that the moon is moving tangentially, but it's also falling at the same time. And so what that does is it, for crying out loud, it gives the moon that circular path around the Earth that we see, the same as what we would deal with if we were talking about that rock. All right. So Newton realized a couple of things right off of the bat. All right. He realized that the moon was falling relative to the Earth. And so the question that he then had was, well, then why doesn't the moon crash into the Earth? All right. And the answer is actually fairly straightforward. The moon doesn't crash into the Earth because it's not only is it moving downward toward the center of toward the center of gravity, right? The middle of the Earth is right here. And so that's where the center of gravity of the Earth is. So not only is the moon actually moving that way toward the center of the Earth, but at the same time, it's got this horizontal or tangential velocity that we see up here with this arrow, all right? And so it's moving toward the right of your screen and downward at the same time, and it forms this little dotted line that is parabolic in nature. All right. So not only is the moon falling toward the Earth, it's also moving in a path that is tangential to the Earth. Okay. Now, if you have any questions about that, it's please let me know. Send me an email or do whatever it is that you need to do to get in touch with me. But that is section 12.2. There is no homework assignment for tonight, so enjoy your Wednesday. All right. Okay. Have a great day.